Right, welcome here again to You Can Do It Math. So we're doing the October-November 2022 paper 33. Let's jump into it. List all the factors of 68. Factors, remember, numbers that can divide into 68. They always come in pairs. Easiest one to find is 1 and 68. Because 1 times 68 is 68. Then let's see, this is an even number, so 2 will go in there. Alright, 2 times 1 is 68. That's easy because half of 6 is 3 and half of 8 is 4. So 2 times 34 will be 68. Next one, does 3 go into 68? Well, if you add the 6 and the 8 together, you get 14. 3 doesn't go into 40, so it doesn't go into 68. The next one is 4. Can we divide 68 by 4? You know what? I got a calculator. Let's use it. Let's see, 68 divided by 4, yep, 17. So 4 and 17. 5, obviously not, because it doesn't go in 68, because it doesn't end in a 0, 5. 6, no, because 66, 6 times 11 is 66. 7, 68 divided by 7, no. 8, 68 divided by 8, no, because 64, that's not going to work. 9, no, you can't divide 68 by 9, of course not. 10, no, because it's not a multiple of 10. 11, no, because 11 times 7 goes 66, 77. 12, 68 divided by 12, no, because 12 times 5 is 60. 13, what about 13? 68 divided by 13. Nope, doesn't work. 68 divided by 14. Nope. 68 divided by 15. No, again, 15 like the 5 times table ends in a 0 or a 5. 16. 68 divided by 16. Nope. 68 divided by 7. No, wait. 68 divided by 17. Yes, but we already have the 17. There it is. And that's it. When we got the number, we already have, we know we got them all. So it would be 1, 2, 4, 17, 34, and 68. Yeah, so when it says list all the factors, you need to find all of them. Okay, as you will see on the mark scheme. There they are. Okay, you only get 1 mark if you got 4 or 5 correct and no extras, or 6 correct and an extra, right? So you have to have them all and have to have them all correct. Question B, put 1 pair of brackets into each calculation to make it correct. Okay, let's see, just bit mass. Remember bit mass. First brackets, then indices, then divide, then multiply, then add, then subtract. So as things are here now, we will do the multiplication first. In fact, we can do it on our calculator. It will be 3 times 5. The calculator will work out first, and then it will add the 7. Which 15 plus 7 is 22 minus 1 is 21. Okay, so maybe we should just play around a little bit, right? Let's put the brackets in there. That means that we'll now subtract the 5 from the 1 first, which will be 4. 4 times 3 is 12, plus 7 is 19. There we go. Okay, just need to play around. So kind of first unlucky. Right, second one, same thing, yeah? You will do the division first. So 16 divided by 2 is 8. And then add the 12 and then the 5. So that would be 25. Well, you can check that with your calculator. 25, yeah? Now, if we put the brackets here, it will add the 2 and the 5 together. First, that was 7. 16 divided by 7, that will give us a decimal answer. That will not work. Okay, so let's try to put the brackets at the beginning. So that will do the 12 plus the 16 first, which is 28. 28 divided by 2 is 14, plus 5 is 19. So yeah, as you can see, that is the one that works. Okay, and there it is. We can see the answer. 1 mark each. So, not too difficult. Reciprocal, remember what that means. It means you swap it around. So it's 7 over 2. 10 to the power of 0. Anything to the power of 0 is always 1. But if you do forget, whip out your calculator and just put it in. 1 it is. Okay. See, you can change the 7 over 2 to decimal or mixed fraction, but just 7 over 2 is good enough. Right, next one. I mean, this is just calculated questions. You got your calculator, use it, type it in. Make sure you know how to put any index there using the right buttons. So that gives us 90. Next one, square root 3. Make sure you use the side arrow. I mean, if it goes like this, I'm still square rooting. Use the arrow times square root 12. Okay, and that gives us 6. And the last one, 5 to the power of, use this negative button, minus 3. Okay, as a fraction, it doesn't matter, or a decimal. It doesn't say how we need to write it. So you can write it as a fraction or a decimal. And we got them all correct. Right, writing numbers from in size, it's best to write them all as decimals. So the first one there, square root 10, is 3.1622, etc. I think like 4 digits should be enough. Okay, then we got 3.142. We can add a 0 there, so it's easier to compare. Okay, next one, 1.8 squared, 3.24. Again, you can add some zeros to look the same. Pi, we know that one, 3.14. Have you memorized it? You don't have to calculate it, we'll tell you. 3.1415, etc. And the last one, 22 over 7. 22 divided by 7, 3.1428. Right, now make sure you do it the right way, right? Smallest. Don't start with the biggest. You don't understand that students does it the wrong way around. Right, so which one will be the smallest? Let's see. Well, it will be 3.14. So this one, or this one. Okay. And 3.41, see the other ones has got a 2, so this one will be the smallest, which was the pi, second last one. Then we got these two left, 3.1420, 3.1428, so the 420, or which is just 3.142, that one is smaller, so you don't have to write the 0. And then of course this one, the last one, which was 22 over 7. Right, then we only got 2 left. 3.16 obviously is smaller, so that was the first one, square root 10. And then the middle one, 1.8 squared. Right, let's see what the mark scheme says. Pi, yeah, there they are. Okay, if you got one in the wrong order, you get 1 mark. And you can get 1 mark for after having changed. So then if you get it wrong, you get marks for changing them to decimals. Okay. Sweet. Okay, read this question carefully, because people don't read it carefully. By writing each number in the calculation correct to one significant figure, work an estimate. You don't know how many students pick up the calculator and they type it in and they write the answer. It's like they don't read the question. You must show what you're working on. So the first thing we need to do is we need to round everything to one significant figure. That means we need to round it to the first digit. The first one, 136, the first digit is a 1. It stays a 1 because next to the 1 is a 3. Okay. But we need to show that that 1 is not a units 1. That 1 is in the position of the 100. So we need to write 100 because we can't round 136 to 1. We need to round 136 to 100. Next one, 47.2, the first significant figure there is the 4, but next to the 4 is a 7, so we need to round it up. Remember, a 5, a 6, a 7, an 8, or 9, we round it up. So that 4 becomes a 5, and again, it's not a 4, it's a 40, so we need to put the 0 to see how it means that 47.2 was rounded to 50. Next one, 62.9. Next to the 6 is a 2, so it stays the same. Add the 0 because we round 62 to 60, not to 6. Last one, first significant figure there is a 1. Next to the 1 is an 8, so again we need to round it up. And we need to show that this is a 20. Okay. Now we can work this out. 100 plus 50 is 150. That's the whole idea of an estimate, that you're able to do it without a calculator, right? 60 divided by 20 is 3. 150 divided by 3 will be 50. That's what they want. When they say estimated, rounded, show all your working. Then you get 1 mark for all the correct rounding. And then 50, correct answer only, so there's no other thing you can write there, and not from wrong working. So that means if you don't have that 100 plus 50, 60 divided by 20, yeah, if you don't have that, you don't get that last mark. Alright, 4.73 as an ordinary number. We can do this without a calculator and then do it with a calculator, okay? So 4.73, we're now going to multiply it by a 1 with 6 zeros. This is a million. So it means we move that decimal point 1, 2, 3, 4, 5, 6 spaces there, and we fill these spaces with zeros. And that's the answer. 4,730,000. Alright, you can check it with your calculator. Okay, to put in a number in standard form, you put 4.73, press this button in the middle at the bottom, and then press the power, and there it is. Done it for us. As easy as that. Okay, and there you are. Oh, what happened there? Okay. A prime number between 30 and 40. Remember, what's a prime number? A number that has only 2 factors. Only 2 numbers can divide in it, like 2, 3, not 4, which 4 can be divided by 1, 2, and 4, 5, 7, etc. Now we need to find one between 30 and 40. There's not going to be even number, because we can, the only even number that's a prime number is 2. Alright, all the other prime numbers is odd numbers. So the first number I could think of there is 31. What about 31? Is there anything that can divide into 31 other than 1 and 31? Not 2, not 3, not 4, not 5, not 6, 7. Okay? That's it, 31. Easy as that. Is there other ones? Yeah, maybe 37. Not 39. 39 you can divide by 3. Not 35 you can divide by 5. Not 33 you can divide by 3 and 11. So yeah, 31 or 37. There they are. Question 2 shows us a bar chart. Number of people who visit a beach in each month of the year. Okay, I bet this is the southern hemisphere because look, the summer there when people go to the beach is January, October, November, December. And then it's winter in the southern hemisphere in May, June, July. So don't go to the beach, man. Alright, estimate the number of people who visit the beach in November. So we look at November. Alright, it's highlighted. Nice green. November is over here. So let's look at that bar carefully. Right, it's between 600 and 700. It's much more higher than closer to 700. So I would say about 680. Okay, but I'm sure they've got some leniency here. Say anything between 660 and 690. So you can have 670, 680, 690. Any integer, that's weird. So they say no decimals. No 681.5. But 681, that's fine. Okay. Okay, here shows the temperature at the beach. Yeah, definitely look at July, August is the coldest. And where is it cold? July, August in Australia or South Africa or Argentina, you know, those places, which is upside down. Okay, Southern Hemisphere. And then in December and January, they have Christmas in the sun with fake snow. Okay, I mean, fake snow like cotton wool, not anything cold. Anyway, Mario says that more people visit the beach when the temperature is warmer. Is he correct? Explain your answer by comparing the bar chart and the table. Okay, so first you need to say, is he correct? Definitely yes, he is. Alright, so you start with yes. And then use specific numbers. Okay. The months of January and December is when most people visited the beach. This is also the hottest 2 months of the year. That's what I would write. Right, my handwriting there not very beautiful, but it should do it. Yes, tallest bars November, December and January occur when temperature is its highest or equivalent. So I believe I get the mark there. Okay, name the specific months. That's important. Right, switching to the camera view, we're doing here question 2b. So scale drawing. So everything is to scale. See, it doesn't say not to scale. 2 lifeguards. L and M on a beach. Okay, the scale is 1 centimeter represents 50 meters. So find the actual distance between L and M. So first we need to find the actual distance on the paper, first of all, of course. And if we measure that, you see mine says, starting at 0, looks like an exact 7 centimeters. Right, so I minus 7 centimeters. Oh, let's write the type below. 7 centimeters. So now we need to find how many meters that is. Of course, we're multiplying the scale by 7. So 50 times 7 is 350 meters. Now that is my answer on my paper. Okay, but I have printed the paper and it has changed the scale slightly depending on the printer and the computer I send it from. Now if we look at the mark scheme, the actual mark scheme, and this would have been a Cambridge official paper, this length is actually 7.3. Okay, and depending on how you're doing this, how you printed your paper, you might get a slightly different answer. Okay, and if it's 7.3, you get 365 meters. Alright, either way, you need to multiply 50 by whatever your length is there, and then you get the meter. So the official answer is 365, but like I said, mine is different because when I print it, the scale changes. So be careful with that. Okay, 365. Next one says measure the bearing of M from L. That's the important part, from L. That means we're going to have to put our protractor at L. We're going to measure from here. But before we do that, we need to connect it. Okay? Draw a line from L to M. Okay, imagine it's like 2 towns. You're going from the one to the other. So we need to measure from there. So it's usually the second one that we measure from. Right, now remember the rules of bearings. First of all, we need to put the protractor, the middle, on the L, and we need to have a 0 at the top because north is always 0, so always like this. And then we always measure clockwise, always this way around. So the 0 being at the top, we're going to use the outside numbers and make sure you're as accurate as possible. There's 140. 1, 2, 3. I think 143 is what mine shows. 143 degrees. Looking at the mark scheme, yeah, that's exactly what they want. And the mark scheme, they don't give you any other option than that. So you need to be accurate and on Exactly. Right, question 3. A boat B is 300 meters from M on a bearing of 68. On the scale drawing, mark the position of B. So we're going to start here with the bearing. And now again, look at that word. There's from M. So that means we're going to put the protractor at M. Right, let me get my protractor at M. And again, follow those rules of it being in the middle there accurately. 0 at the top, and remember it was a bearing of 68, so we use the outside numbers. We go to 60, and then 65, 66, 67, 68, and I make a little mark there. Okay, so that's the direction that the boat is in. The next thing now is the 300 meters. We need to change those 300 meters now to centimeters. Now remember, the scale is 1 centimeter to 50 meters, and I tell us 300 meters. How do we go from 50 to 300? Well, we do the opposite. We do 300 divided by 50. What would that be? 60, is it not? Or 6? It would be 6, of course. Yeah, so that means 50 times 6, 300. So we multiply this side. 1 times 6 is 6 centimeters. So that is what it is on the map or on the exam. Okay, so remember this dot we made here before, that only shows us the direction. It doesn't show us how long the line is. So we need to draw now the line exactly 6 centimeters long. So we're going to go through the dot until we get to 6. And there we go. Okay. Mark the position of B, it says. Mark the position of B. So there, that is B. You can draw a little cross to make it clear, and you label it B. Right, so to get full marks here, you need to have this angle 68 degrees, and you have to have the length of that line exactly 6 centimeters. Right, on to question number 3. The population of Alaska is 730,720. Write this number in words. Okay, so let's do that. So 735,720. Is that correct? 735,720. The and is optional. Okay. The land area of Alaska is 1,477,300 square kilometers. Work out the average number of people per square kilometer. People per square. This per. Think of it as a division sign. Okay. That looks like a percentage sign. A division per. People per square kilometers. So what we need to do, okay, is write down the people and divide it by, okay, that's how you write people per square kilometer. Square kilometer. People per square kilometer. Let's do that. So, do it over here. Okay, so what we get is 0.49801. What does it mean? For every square kilometer, there's about half a person. Or if you're a person standing in Alaska, you will have about 2 square kilometers around you for yourself, if I understand that correct. Okay, there it is, of course. If you're going to round it to 3 significant figures, 0.498 Just don't round it to anything less. Right, Anchorage got 291,830 people. What percentage of the population of Alaska live in Anchorage? So first we need to write that 291,830 out of the total, which was 735,720, 735,720. Now we're going to do that on the calculator. Okay. That will give us a decimal value, right? To change it to percentage, we just times that by 100, of course. And then we have the answer. Times that by 100. And that will be 39.665. Etc. Rounded to 3 significant figures. Next to that 6 is another 6, so when you round it up, 39.7. Don't round it wrong and lose a mark. 39.7, or if you write the unrounded answer, you also get full marks. Well, that one full mark. The length L kilometer of a race is 1,569 kilometers. This must be still Alaska where they do those dog sled races. Correct to the nearest kilometer. When you see these words, correct to the nearest, it means this number has been rounded. Okay, so that's not the actual answer. This actual answer was a number and they rounded it to that. Okay, one way to always get this right is to take what it's the nearest, what was it rounded? Kilometers. Think about it of 1 kilometer. It was rounded to the nearest 1 kilometer. Divide that by 2, which will give you half a kilometer. Now we need to take this number and subtract half a kilometer. That will give us the lower bound. Okay, which of course is 1,568.5. That will be the lower bound. Okay, and then to get the upper bound, okay, that's the lower bound because when you round 1,568.5 to the nearest kilometer, it rounds up to 1,569. Okay, to get the upper bound, we need to add 0.5, which of course is 1,569.5. Now, I know if you're going to round 1,569.5, you're going to round it to 1,570, no? But that's why there's no line here. So it means less than that number, but not the number. Okay, and that's why that's the upper bound. Okay, and that is the correct answer. That's what they want. Okay, so don't write 1,569.49 recurring. Okay, because it is right. That's the number you round down. But because they put this sign here, this sign, the less than, but not equal, you need to write that. Question C. Mountains, my favorite. Temperature at the top of the mountains, as you can see, it's freezing cold. Right, so the difference in the height of the two mountains. So that's just a subtraction here. Two very high mountains, by the way. $2,659. Don't round this because it's an exact answer. Okay, exact answer. No long decimals. Don't round it. Okay. Find the difference between the maximum temperature and the minimum temperature at the top of Denali. So top of Denali, first one here, the difference in temperature. Okay, so that's like minus 20 minus 9. 2 minuses makes a plus. That's going to be 11 degrees. Okay, I know it's going to look like minus 11, but I think just 11 degrees is fine. Will you get your mark if you put minus? I don't think so, actually. Okay. Yeah. Or is it better if you do minus 9 minus 20? That's minus 9 plus 20. Yeah, this is the difference. It's 11. The maximum temperature at the top of Everest was 27 degrees colder than the maximum temperature at the top of Denali. Complete the table. So, if we need to go, we're at minus 9. Damn, that's cold. And we need to go colder. We subtract from that 27. Of course, that will be minus 35. Minus 35. Okay, if you're not sure, check it with your calculator. Yeah, definitely check it with your calculator, because if you make silly mistakes like I do, you don't want to lose. Oh, it was minus 9. It's getting late here. Okay. 36 minus 36 degrees Celsius. Right, here we got a good old distance time graph. And this is Tia cycling along the path. Okay. Now remember, with distance time graphs, the steeper the line is, the faster she goes. So you can look here, from 10 o'clock to 20 past 10, she was cycling at a good pace, but then she picked up pace because the gradient goes steeper, so she's cycling faster. Then she gets tired, or she reaches Ocean Park, rather, at 10:40, and she stops. That's when it's horizontal. And then she cycles back for 1 hour, from 11 o'clock to 12 o'clock, at a steady pace back to Bay Park. So when is she cycling the fastest? That's when the gradient is the steepest. Okay. Now we can work this out, but I'm pretty clear that the line goes the steepest from here to there. Okay. That is when it's the steepest. That will be when she cycles the fastest. It says between which two times. So we go down from there. 10:20 and 10:40. Yeah. For 20 minutes, she was really going at it. 10:20, 10:40. And he leaves Bay Park at 10:20 and runs to Sandy Cove at a constant speed of 8 kilometers per hour. He then stops to rest until 12. On the travel curve, draw Andy's journey. Okay. So let's just clear the clutter. And we're going to draw a journey now. So you get out your pencil and ruler. And now we think. Okay. At 10:20, Andy leaves Bay Park. So 10:20 is there. Right. He runs to Sandy Cove. There's Sandy Cove. So we are going to, in line with that, there's somewhere we're going to stop. At a constant speed of 8 kilometers per hour. Okay, what does 8 kilometers per hour looks like? It means like in 1 hour you travel 8 kilometers. Okay, so from 10:20 to 11:20, if he runs 8 kilometers per hour, in that hour he should cover 8 kilometers. So at 11:20 he needs to be 8 kilometers away. So that gives us a good idea of what that angle should, that line steepness should look like this. Okay, now remember he's going to Sandy Cove, so we need to stop at 12 kilometers. That's how far it is away. Okay, gonna have to redo that line. Luckily I used a pencil to draw it. Struggling a little bit on this smooth screen. That's it. So you see, in 1 hour, this is 1 hour, he traveled 8 kilometers, and that's 8 kilometers per hour. He stopped when he got to Sandy Cove. Okay. To rest at 12. To rest until 12. Then he stops to rest until 12. So then, of course, he reached Sandy Cove a bit earlier and then he rests. So we need the flat line there. Rest is not moving. Okay. So line from 10:20, 0 to 11:50, 12. 11:50, yeah, that's where we are. Between 11:40, that was that. And then from that's the flat part they describe from 11:50, 12 to 12:12. Okay, that's the flat part, so that is correct. Write down the time and the distance from Bay Park when Tia and Andy pass each other. Now, there we go, where the two lines cross, of course. Okay, so what would be the time? You see that is what, exactly halfway? Between 11:20 and 11:40, which will be 11:30, 11:30. And the distance, we need to go across that was a bit harder. It's a bit less than 10 kilometers. So wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So each square must be 0.2. So this is 8.2, 8.4, 8.6. I would say about 8.8 kilometers is my estimate. Let's see if I will get my marks. Oh, no, this is bad. 11:30. Of course, it's 0.4. Because this here will be 10 o'clock. So you see how careful you need to be with the scale. Okay, you need to be very careful with the scale. You need to look carefully or you won't get your marks. Okay, so let's look at that scale. Halfway will be 10. And there's 1, so each square is 0.4. So this will be 8.4. Let's make this a bit thinner. 8.6. 8.8. No, you're not doing this all wrong. That will be 8.4, 8.8, 9.2, 9.6, 10. So that's why the correct answer here would have been 9.6 is my opinion. Okay, so look carefully. That's a tricky one, yeah? 9.6, yeah, they got 9.2 to 9.6. Look at it carefully. In June, the number of cyclists using the path was 3,546. In July, the number of cyclists using the path was 4,067. The weather must be getting nicer. Work out the percentage increase in the number of cyclists from June to July. So first we need to get the actual increase. Actual increase, how many more cyclists is that? So we subtract the one from the other. $521 more cyclists. Alright, so then we write it as a fraction out of the original amount. There's always the original amount that was first. Okay, and if we put that in, we can just divide that by 3, 5, 4, 6. Okay, that gives us the decimal value. So we times it by 100. And there we go, it's a 14.692 set a percentage increase. If you're going to round it to 3 significant figures, next to the 6 is a 9, so that's 14.7. 14.7, or the unrounded answer, gets you full marks. Right, there's walkers and runners. Everybody's using this path. Write the ratio of walkers to runners in its simplest form. So let's just, first of the walkers is 432. The runners is 528. And now we need to simplify it. We need to divide both sides by the same number. What could that possibly be? Let's start, just divide with both even numbers. So let's half both the numbers, right? 432 divided by 2. 216 this side. And that side would be 528 divided by 2. 264. Okay, it looks like we're going to be dividing this by 4 for a while. Now let's do that. Let's do 216 divided by 2 divided by 2 divided by 2. That was 3 2's, right? So that's like 8. 216 divided by 8. Can we divide 264 by 8? Yeah, so let's divide both by 8. Remember, this was 27, and the other one is 33. I bet you can spot what goes into both of those ones. It's 3, of course. So that'll be 11. And then we know we can't divide anymore. Okay, quickest way, of course, would have been dividing it by 16. To make a number. Anyway, 9 and 11. I mean, there's quicker ways to do this, but we got it. Oh my goodness. In the same week, the ratio of cyclists and walkers using the path. Okay, wait. Let's just write down all this information down. Okay. We got the cyclists, the walkers, and the runners. Here we got the cyclists and the walkers is 14 to 3. And then we got the walkers and the runners was 9 to 11. Okay. You see now? That makes a bit more sense. Okay. Right. What other information do we have? Well, we do have the total number of walkers and runners. 432 walkers. So I think actually we need to write that down. So 432 walkers, 528 runners. So that's the actual amounts written as a ratio. The cyclists to walkers, that is a simplified amount. So how do we get from 432 to 3? Let's divide that. 432 divided by 3, because this is both represents the walkers. That's 144. Okay, so that means we need to multiply 3 times 144 is 432. Since these are ratios, is always equivalent, we need to do the same with that 14. Do 14 times 144. And there we go. 2016 cyclists. So now we just need to add that up. 2016 plus 432 plus 528. $2,976. Let's see what we get marks here for. Yep, 296. You get a mark for 2016. You get a mark for dividing. Well, we got it. Right, into question 5. Everything is in centimeters, they tell us. They tell us it's a rectangle, we can see that. Show that the length is 5x plus 8. Well, let's start just adding the length together. This is x plus 4. Then we add that x over 2. Then we add the 2x. Then we add another x over 2. What does x over 2 mean, by the way? It means x divided by 2. It means a half x. And then x plus 4. Okay. Now, I'm going to go back to this x over 2. X over 2. We can also write it as a half x. It's the same thing. Because you divide something by 2, you times it by half. It's the same thing. So what's a half plus a half? 1, of course. So this x over 2 plus x over 2. Another way of saying it is x over 2 plus x over 2 has got the same denominator. X plus x is 2x. 2 divided by 2. That would be just x. So x over 2 plus x over 2 gives us x. If we add it to this x, that's 3x. To that x, that's 4x. Plus this, that's 1x. Plus 2x. 4x plus 5x, yeah. X plus 2x plus x is 4x plus 2 half x's is 5x's, yep. And then 4 plus 4 is 8. Right, so yeah, all they want to see actually is you writing it like this part here. That's what gives you the mark. The area of ABCD is 360 centimeters squared. How do you work out the area of a rectangle? Well, you take the length, which they've just given us, is 5x plus 8. And you multiply it by the height. So that means 5x plus 8 times 15. Is this correct? No, because this is bit math, means we only do 8 times 15. We need to multiply everything by 15. Will give us the answer 360. Or a better way to write it, 15 times 5x plus 8. You put it just in front of the bracket. It means you multiply everything in the bracket. Now we just need to solve it. First get rid of the 15, divide both sides by 15, or divide the 15 on the other side. So that will be 360 divided by 15. So that gives us 5x plus 8 equals 24. Next step is subtract that 8, which leaves us with 5x equals 24 minus 8 equals 16. And then divide the 5. Okay. Doesn't tell us how to write this. I'm sure if you write 16 over 5, that's good enough. But if you write it as a mixed number, 3 and 1/5, or as a decimal, 3.2. I'm sure that will be fine. 3.2. Yeah, it doesn't say or equivalent. I'm sure. You'll get your marks for any one of those. Okay. The total shaded area is the next thing they want to know. Okay. How are we going to do that? Well, the shaded area is a rectangle as well, isn't it? So x over 2, we know what x is now. We know x is 3.2. So if you got x over 2, and we know x is 3.2, we can substitute the x for 3.2. 3.2 divided by 2, of course, will give us 1.6. So that means the width of the shaded area is 1.6. Got the height, which is over there, 15. So all we need to do now is do 1.6 times 15, and that will give us the area of one of those shaded bars. But there's 2 of them, so we're going to times it by 2. So here we go. 48 centimeters square. Tough, they only give 1 mark, so you got 48 or you don't. Right. Right, we're on to this box and a solid cuboid next to it. Show that the maximum of 24 of these cuboids will fit inside the box. Alright, this is not volume, really. It's more about practicality. Okay, think about this. If you're going to pack these boxes, put it in flat, that's 15, that's 30. So you'll only fit 2 boxes lengthwise. Okay, then this is 6 and that's 18. So you'll be able to fit 3 stacked on top of each other like this. Okay, so you'll fit 3 that way. Alright, and then this is 15. What is 65 divided by 15? I do 65 divided by 15 because it's 65 and 15 there. Okay, 4.3. That means we will fit 1, 2, 3, 4. Let me draw it a bit bigger. Okay, 1, 2, 3, 4, and there will be a space left. Remember, that's 3 high. So they will fit like this, and there will be a space left at the end. There will be a 0.3 recurring, a third of a box space left. So now you can imagine me stacking it in there. Okay, so 3 boxes high, 2 boxes wide, and 4 boxes long. Now that means that we can now multiply 3 times 2 times 4 is 24 boxes. Show that the maximum 24. Okay, do you think I've done it? Maybe we should write down all the calculations we did. We did 30 divided by 15 is 2 to get the width. We did 18 divided by 6 is 3 to get the height. We did 65 divided by 15 because us 4.3 recurring, so we know only 4 boxes will fit lengthwise. Let's see. They get 3 times 2 times 4. Oh, that was good enough. That was good enough. 3 times 2 times 4 is 24. 24 of these cuboids are placed inside the box. So they fill it up now as much as they can. Calculate the volume of the empty space in the box. Give the units of your answer. Oh my goodness. Let's get the volume of the whole box first. Okay, that's not too hard. 18 times 30 times 65. Okay, so 18 times 30 times 65. That gives us the volume of the whole box. Of course, this was centimeters times centimeters times centimeters, so it's centimeters cubed. Let's write it there. We already get that mark, the units. Now we need to work out. Well, this is not difficult. That's it. Now we're going to pack these boxes inside, 24 of them. So we need to get the volume of this, 6 times 15 times 15. Alright, that will give us the volume of one of the little cuboids. And of course we're going to pack 24 of them in there, so we can times that by 24. Fill it up. So we times that by 24. And that gives us 32,400 centimeters cubed. So if we subtract the 2, we will get what is left. I'm sure there's another way to do this as well, but this one worked for me. So 35100 minus 32,400. 2,700 centimeters cubed it is. Sweet. 3 marks for that and 1 mark for the units. Don't forget that. On to question C, we got a cube here. Remember, cube, all the length is the same, right? So it gives us the surface area. Remember, the surface area is the outside. This and that, and this, and the back there, and that side, and the bottom. Okay, yeah. How many sides are there? 6, like a dice. Okay. So if we take the surface area 486 and we divide it by 6, we'll get this area of one of the faces. Now that would be 81 centimeters square. So let's say that this is 81, that's 81, that's 81. Okay, that's 81 there in the front. Okay, so 81 is the area of the face. So now what we got now is the area of a square. Okay, how do you work out the area of a square? You square root it. So what we need to do now is to square root the 81, and that gives us 9 centimeters. So that means there's always 9. Okay, so that's it. X is 9. Yep. Oh, they got a fancy formula there, or equivalent or better. I'm sure I'll get full marks for my working out. Right, the moment you see parallel lines, immediately think, what are these? Yeah, we got 2 of these. Think for the Z angle, called alternate angles, or remember the other one? The F angles, which is corresponding. Remember these words. Okay. Tattoo them on your hand. No, that's cheating. Just tattoo them on your dog's tail and read it every day. Okay. Find the value of P. So there we go. You look for those Z's and those F's. And yeah, I can immediately see it. There's P. No, the highlighter doesn't want to work. Okay, there's P. You can see the beautiful Z there. Okay, so what would it be? It would be the same as over here, 48 degrees, because they're looking for that word. Don't write Z angles, because alternate angles. I don't think you need to write a very long story here. Okay, what they're looking for is that word alternate. Okay, but put angles in just to be nice. Okay, don't push your luck. Find the value of Q. Alright, we use the Z now. Can we use the F? No. Okay, there are different ways. Give a geometrical reason for your answer, as I say. Okay, there is the other one I haven't told you about. Forgot. Okay, if you learned this one. The one what we call C angles. Okay, they go interior. The important thing on co-interior angles is they're not the same, they're equal to 180. Okay, so to get Q, we need to do 180 minus 57. Okay, 180 minus 57. It's 123. Alright, I'm curious, I haven't seen what the mark scheme says, because there's other words for this. Supplementary angles, okay. You can also work out this angle here, which is 180 minus 48. What is that? That's 132. And then you can do angles inside a quadrilateral, which add up to 360. So 360 minus 48, 132 and 57. Should get the same answer we did, 123. Let's check it. Yep, same answer. So then you will write angles in a straight line, angles in a quadrilateral. Let's see what the mark scheme says. Interior angles, then I just say interior as a co-interior, alright, or equivalent. So you don't need to have that long story. Interior angles, co-interior. You don't have to put the co. I don't know which country where they learn that, but it's a bit unnecessary. Right, we're continuing here with question 6b. And let's read the information they give us very carefully. G is a point on the circle center O. So they're referring to this point here. And they tell us that's the middle of the circle. Okay, when they tell us stuff, it's for a reason. Okay, so what I think they're trying to imply here is this is a radius. This is the radius of the circle, yeah? FHJ, there's F, there's H, there's J, is a tangent to the circle G. Okay, so it means this is a tangent. So immediately you remember that circle theorem. Alright, what does that circle theorem say? Right, it says that the radius and a tangent always meets at 90 degrees. You see that? You can make the circle bigger, smaller. Yeah, see, it's always 90 degrees. Right, so that means we know that this angle here is 90 degrees. And then they tell OH is equal to HJ. So those two angles are the same size. Write down the mathematical name of triangle OHJ. Let's just clear the clutter. Okay, we know that angle is 90 there. Right? Triangle OHJ is that triangle there. Okay, what does it have? Two lines. Now remember, a triangle, we've got two sides the same length. Okay, it's called an isosceles triangle. So how you spell it? Isosceles. Isosceles. Okay, my handwriting is a bit ugly there. Okay, what else do we know about a isosceles triangle? Is that the two base angles are always equal. So meaning the two angles at the end of those lines. And here the two angles is this one, 28, and that one, the x. So that means angle x is 28 degrees. Next one, they say find the value y. Right, so what do we have? Let's just clear all of this. Alright, so remember what we said, we already found out, is this angle here between the radius and the tangent is 90 degrees. Okay, and we just worked out x is 28. And angle y is an angle in this big triangle here. Triangle OGJ. Okay, and all the angles in a triangle always add up to 180 degrees. So if we subtract from that the 90 degrees, the 28 degrees, that is x, and the other 28 degrees, which is also there, we'll be left with only this angle, which is y. So we need to subtract 28 degrees twice. Okay, so easy with a calculator. $34 it is. 34 it is. You see, we're subtracting those angles, and your answer, which is 28 for us, you got the right answer. Right, so this shows us how much a ticket costs and how far the plane flies. You see, like, so if you pay $360 for this ticket, you're going to get on a plane that flies 1,650 kilometers. Okay, and then that point has been plotted on the graph. So let's see, let's zoom out a little bit. $360 would be there, and that you go down, that's the 1,650 kilometers. Okay. So what do they want from us? Complete the scatter diagram. The first 8 points have been plotted. So you see there's a grey. These points have been plotted. They want us now to plot these points here. Okay. Use a ruler and show how you plot them, because then the examiner will think you're super smart and you'll get your marks more easily. So first we go to 715. Let's look at that. Alright. Where will be that 15? There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares between the values. So that means any square should be 10. So we got 710. 715 will be between right about there. Okay, so you want to draw very light. Let's make it light. A light line going across. Okay. This is difficult on the smooth. Okay, so that, and then that point we got to plot with is 3,850. So where would that be? Well, there's got 3,000 here. Again, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3,800 will be there, and 50 will be halfway. So that's where we will need to draw the line. Let's zoom out a little bit. Okay, so we go up from there. Okay, remember you do this in pencil very lightly, because then the point we want to plot will be there. Exact. If you draw the lines, then the examiner will see, this person knows what they're doing, they're very accurate, let's give them super good marks. Right, next one, 530. Rather than just looking like you guessed it, yeah? Make it easy for them to mark your paper and they will give you marks more easily. Makes common sense. So 530 should around be about there somewhere. Oh, my line is a bit crooked. And 2,900. So that will be there. Right? 100, 200, 300, 400, 500, 600, 900, yes. And we go up. Okay, and then you mark clearly that point. The line is a bit high. Okay, so those lines will just make it easier for them to mark it. What type of correlation is shown in this scatter graph? Okay, so if we look at that, we got a general pattern. Yeah, no, let's use that. General pattern going up like this, you see? And that will be called a positive, of course, positive correlation. Okay, all you need to do is write is positive. As the one value goes up, the other one goes up. The more you pay, the further you fly, generally speaking. Okay, positive. Well, the plot's pointed. On one flight, the ticket price is much more expensive per kilometer traveled than on all of the other flights. Draw a ring around this point on the scatter graph. So which one is much more expensive than all the other ones? Yeah, now the question is, more expensive per kilometer. Okay, so per kilometer, that's important, per kilometer, because this ticket here is obviously, let's just do this in pencil. This is the most expensive kilometer ticket. You pay the most for it, I would say. Okay, but it is also the one that takes you the furthest. Okay, so is it an unfair price? No, because you pay a lot more because you go further. Okay, so per kilometer, it's fine. It makes sense. I think the one I refer to is this one over here. You can see this one is a bit out wavered out. So I'm going to circle this one in pen. Okay, because this one, you're not going that far. You're only going 3,000. Okay, so these other ones, right, like this one down here and that one over there, they are cheaper, but you're going further. And this one over here, it costs the same price, but you go a lot further. So per kilometer, that one is the most expensive. Per kilometer. If you pay a lot, you don't go further. And that's what they mean. Ring around 3,900. So yeah, it's the one that's $900, only takes you 3,000 kilometers. So you have a circle there. Draw a line of best fit on the scatter graph. Okay, zoom out a bit. Now that would be a line that goes as close as possible to all the dots having the same amount above and below. So first, let's do this in a funny color. What its line of best fit would not look like. Okay, it will not look like this, obviously. Okay. We have roughly the same amount blown up, but it doesn't follow the pattern, so that's wrong. Okay, you don't want to draw it too low. Okay, that would be wrong. Because like a 1 below, and I got all of them above. And the same, you wouldn't want to draw it too high. Oh, that was the wrong way. You don't want to draw it too high. Because again, now we got only one dot there, the rest below. So generally what you would like to do is, and now I'm going to draw the right one, which you can do in pencil. You want to start as close as possible to the lowest value, and as close as to the top value. You don't necessarily have to start from 0. Okay? And then try to get the same amount, following the pattern, of crosses below and above. Okay, something like this. So we try that. Let's check. I've got 1, 2, 3, 4, 5 below, only 2. So I think that's a bit too high. Let's try it a bit lower. Let's try it about this. We got 1, 2, 3, 4, 5 below, 1, 2, 3, 4, 5 above. That's a good line of best fit. Okay, and look here, yeah, we don't have to start at 0. Start somewhere near the lowest value. We might be going a bit too far, somewhere near the top value. Okay, and the mark scheme is not very helpful here, telling you what's the right answer. Another plane travels 4,500 kilometers. Use your line of best fit to estimate the ticket price for this flight. Again, okay, draw some lines. I'll be quiet. Draw some lines in pencil very lightly, so the examiner sees how you know what you're doing. Okay, so the plane travels 4,500 kilometers. Where would that be? That would be there in the middle. So we're going to draw a line going up till we meet our line of best fit, because it says use your line of best fit. Okay, so we meet our line and then we draw a line across, and that's where we lead the value from. Okay, so here let's see, 710, 20, 30, 40, 45. I would say 745 roughly. Okay, so that's my answer, $745. Yours probably might be something different, because you got a different line of best fit. Let's see what the mark scheme says. Anything between 720 and 760. Yeah, so I get mine right. So 719, 0 mark. 761, 0. Anything between 720. Okay, but there is a follow through mark here available. See, follow through, which means if your line of best fit is wrong, but you use it to get your answer, you can still get this mark, even though it's not between 720 and 760. That is where these light green lines come in. It's very important. If the examiner sees you draw those lines, you know what you're doing, you'll get that follow through mark. So draw the lines, okay. Question B, the ticket price for a flight is $522. The exchange rate is €1 is 1.16. Find the price in euros. So what? We got €1 equals $1.16. Then they give us 522. So how do we change one? What do we multiply? 1.16 times what gives us 522? We can do that calculation backwards. So 522 divided by 1.16. 450. Meaning 1.16 times 450. To do the same here, we multiply that by 450. And that's easy. So it's 450 euros. Okay, and the euro sign is there already. Yep. Well, we're going to Copenhagen from London. It's 1 hour 24 minutes. Work out the average speed in kilometers per hour. Alright, so remember now your triangle. Okay. The formula for speed, we already have the formula here. Kilometers being distance, per meaning divide, hour meaning time. Speed, distance, time. That's the formula, right? So to work out the speed, you take the distance, which is 939, and divide it by the time, which is 1 hour 24 minutes. There's just a problem here. How do I put 24 minutes on my calculator? It is not 1.24. Let me just make that clear. 1 hour 24 minutes is not 1.24. Okay, that is wrong. Don't do that. Okay, what is correct is to recognize that 1 hour 24 minutes is the same as 1 hour and 24 minutes out of 60. Time, we stop counting at 60, whereas decimals we count up to 100. Okay, so that will be 1 point, right, 24 divided by 60, 0.4, so that's 1.4 hours. So when we do this calculation, is 193 divided by 1.4. That's kilometers and that's hours. Okay, so you have to change from the time way of calculating where we stop at 60 to the decimal value where we count up to 100. Okay, that's important. So it's 939 divided by 1.4 hours, and it gives us this very weird answer. 670.714, etc. Okay. Remember, it's a plane, so you can go fast. If you're going to round it to three significant figures, it will be 670, and because there's a 7 there, we round up to 0, 671 kilometers per hour. Okay, 671, that right on the line, or the unrounded answer also gives you full marks. See that? 1.4, that's the important part. Get full marks. Right, the amount of fuel used is 3.89 kilogram of fuel per kilometer. That sounds like a lot. Carbon emissions is 3.15 kilogram for each kilogram of fuel used. Work out the carbon emissions in kilograms for this flight. Oh, wait. Let's first work out how many kilograms of fuel. So, how many kilometers do we travel? 939. Travel 939 kilometers times this value here, 3.89. That gives us the kilograms that are fuel used. So we've used 3,652.71 kilograms of fuel. Okay, don't round this because this is not your final answer. Carbon emissions is 3.15 kilograms for each kilogram of fuel used. So for each 1 kilogram, so now we need to multiply this. 3652.17 times 3.15. It's a lot of carbon emissions. How do they calculate that? It's weird. So all we need to do is then times this by 3.15. And that's a lot of carbon emissions. 11506.03, etc. If you're going to round this now, 3 significant figures, it'll be 11500 kilograms. Although, yeah, I don't know. 11500, that's what I said, 1,500 kilograms. Or the unrounded answer. You just need to multiply it all together. A lot of carbon emissions, man. Think again before you want to fly next time. Right, we're back on to the camera and we're doing question 8, transformations. So the first question here tells us, draw the image of shape A, so make sure you look that one there, after reflection in the line y equals minus 1. So let's first draw this line y equals minus 1. Right, y refers to the y-axis, of course, and minus 1 is right there. Okay, so the line y equals minus 1 is a line that goes through minus 1 on the y-axis, like this. Okay, so that would be the line y equals minus 1. Right, now we need to reflect the shape. Okay, there's different ways of doing this. I am just going to count squares. So, you see this corner here? It is 2 squares away from this line. Don't confuse it with the x-axis, this line here. So we got 2 squares on the other side. So that will be now its new position. This one here is same, 1, 2, 1, 2. This angle just above it is 1, 2, 3 squares. So we got 1, 2, 3 squares. And this last acute angle there is 1, 2, 3, 4 squares to the line of reflection. So we go down 1, 2, 3, 4. And there we go. That's where the new reflected shape will be. You know, like a mirror image. So just connect the corners and then we will get full marks. There we go. Right. Next, describe fully the single transformation that maps shape A onto shape B. So what could that be? What could take that from there? What is the transformations there is? Let's think about the names. Let's write them down here, right? There is, of course, the reflection, which we just did. What else is there? Then there is translation. This is the one people often spell wrong. And a translation would be if you just move across the page, of course. So let's just roughly trace this shape. Translation would be just moving across. So it keeps the same orientation and the same size. What's the other one? Of course, there's an enlargement. And I think you can see that one coming. Enlargement. And what's the last one? There is, of course, when you spin around, the rotation. So which one could this be? From A to B. What could that possibly be? Okay. Well, it's not a reflection. We just did the reflection. When it flips over. Okay. Could it be a translation? Move all the way there and then move down. No, you see, the orientation has changed. It's not an enlargement, of course, because it's the same size. So the only thing it could be is a rotation. So it's rotated like this. Okay, so that's the first thing we're going to write down here to get 3 marks. First one you see, you write rotation. And now we got 1 mark. Let me put it in red. Okay, tick. 1 out of 3 marks. Right, next thing, of course, is the center. Let's do the center. So you trace the shape, trace it, and that would be, where do we put our pencil? Where's the center? So it rotates there. It's always good to start. Try the center, 0, 0 first. And yeah, look at that. It is in the middle, the origin. Okay, so it rotates from there to there. So we'll write the center of rotation is the point 0, 0. Okay. Lastly, okay, because that of course was our second mark. There's 3 marks. You can also write the origin. Let me just check the mark scheme. Alright, what do they say on the mark scheme? Yeah, 0, 0 is all you need. And then last here is the angle. Okay, how much do we rotate? Well, it's pretty clear. That would be 90, 180, 270. Okay, and look, if I go 180, it doesn't matter if I go this way around or if I go that way around. Okay, so all you need to write here is 180 degrees. You don't have to write clockwise or anti-clockwise because it doesn't matter. You end up in the same place. And that's how you get 3 marks. Okay. Part 3 there, describe fully the single transformation that maps A onto C. So now we're going from A to C, and you know it, yeah, it's getting bigger. So obviously that's an enlargement. Okay. Although enlargement doesn't always get bigger, it can also get smaller, and we still call it enlargement. But this one got bigger. So writing enlargement gives you your first mark. Again, we're going for 3 marks here. So we need to mention 3 things. Next one, how much does it get bigger? That's called the scale factor. So let's write that down. Scale factor. How many times is that bigger? Let's see. This one's got a base of 1 square. This one's got a base of 3 squares. This height here is 2 squares. And there it's 6. So yeah, 3 times bigger. Scale factor 3. Now we got 2 marks. Last one is also, we call it the center. Where does it enlarge from? Okay, to find that, we need to connect corners. Let's start with the acute angle there at the top. So we're going to connect them and continue on to the other side. Right, let's next do the bottom left right angle. Connect them. You see what's happening? They're coming together. Let's do the bottom right angle. Again, it comes together. We can do the last one just for fun. They all come together in one point, and that will be the center of enlargement. And then remember, x-axis first, -7 along the corridor, and then we're not going up or down. So it's -7, 0. And that will be our 3rd mark And you've got it. Let's look at question 4 here. And it says complete the statements. The area of shape A is something times bigger than the area of shape A. Shape C and shape A. So we're looking at shape C and shape A. Area, of course, is square. How many squares fits in there? So the area of shape A, that will be 1 square. And then there we have another half a square. So the total area is 1.5 square. Shape C, let's count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares. Over here we got another half and another half. So these two halves will be another 1 square, and there's another half square there. So it's the 12 plus the 1 plus the half is 13.5 squares. Okay, all we need to do now, get the calculator out, and then we divide 13.5 or 13.5, that's the quick way, divided by 1.5, 1.5. 9 is the answer, so it's 9 times bigger. And we've done it. Right, we're looking at question 8b, a column vector. Like a column vector is 2 numbers, not with a line. So there we got a column vector, not with a line in between. It's not a fraction. And the number at the top tells you how much you go left or right. Okay, of course you go to the right is positive because if it's negative. Number at the bottom tells you how much you go up or down. Up is positive, down is negative. So column vector from A to B means is what do you do to travel from A to B? Well, we're going to have to travel 1, 2, 3 squares to the right, which is positive because we're going to the right, so that's 3. And we're going to have to travel 1, 2, 3, 4 squares up. So there's 3 over 4. Do not draw a line in between. Okay, 3 over 4. Now B is 4 minus 5. So it means we need to move 4 squares to the right because it's positive, and then 5 squares down. And we need to start at B. So starting at B, 4 squares to the right, and then 5 squares down. And that is where we have C. So make sure to mark it clearly. C. Okay, it's at the point 10, 1. Yep, the point 10, 1. Nice. Okay, look at this you do in pencil. And you just leave the answer like that. Okay. Next one, 3p. You see that vector there? Is 5. P is 5 minus 12. And if you put a 3 in front, it means you need to multiply it. 3 times 5 for the top, that's 15. And 3 times minus 12 being minus 36. That's all you do, you put it in front. Yes, we got it right. Next one, vector t, let's write that down, which is 4, 7, minus vector p, which is 5 minus 12. Now we just subtract the top number from the top number. So 4 minus 5 gives us minus 1. And then 7 minus, there's 2 minuses, see? So that's 7 plus 12, which is 19. Because 2 minuses makes a positive, 2 negatives makes a positive. Sweet, got it. Albion. He's got a very unique name, and he's carrying around a bag of counters. Weird guy, Albion. 6 are pink, 8 are blue, and the rest are either green or yellow. He picks one counter at random. The probability that Albion picks a green counter is 2 out of 7. Find the number of yellow counters in the bag. My goodness. What's going on here? Let's write this down. So pink is 6 counters. Blue, there's 8. Then there's some green ones. Don't know how many. And there's some yellow ones. We don't know how many. Okay. We do know it adds up to 35. Okay. So what other information can we deduct from this? Probability that Albion picks a green counter is 2 out of 7. So that means if there were 7 counters, 2 of them would be green. Okay. But there isn't. There's 35 counters. So what that means is that to go from 7 to there, we need to times it by 5. 7 times 5. So there's 5 times more than this ratio shows us. So we're going to do the same over here. We're going to times this by 5. And now we know it must be 10 green counters. Yeah? So 10 it is. We can also deduce how many yellow ones there is, but they're not asking that. And they say the answer is 11. Oh, because they ask I wrote the green ones. So that will be 35 minus the pink ones, minus the blue ones. And that 11? 35 minus 6 minus 8 minus 10. 11 it is. You see? Yeah. Always read the question carefully. Interesting question. B. Matteo, hello Matteo, has a box containing 15 counters, of which 7 are red and 8 are brown. He picks one counter random, notes the color, and replaces it. That's important. He puts it back into the box and then picks another counter random. So 7 out of 15 is red. Then over here, the other 8 out of 15 is brown, because together just need to add up to 15. Because he puts it back, that never changes, because he takes one, looks at it, puts it back. So that's going to stay the same. Complete the diagram. We just done that. Okay, 7 out of 15, 8 out of 15, that's just like I did it now. Right. Calculate the probability that Matteo picks 2 brown counters. So what we're looking at now is going down this pathway. Oh, it's not the highlighter. He picks a brown one and he picks another brown one. So the 2 probabilities is 8 over 15 and 8 over 15. What do we do with that? Well, if we're going to add it, we'll get 16 out of 15, and that's more than 1, and a ratio can never be more than 1. Okay, so that is wrong. What we do need to do, which will make more sense when you move along a tree diagram, you need to multiply. Okay, so let's do that on the calculator. 8 over 15 times 8 over 15. And that's the answer. Is that the simplest form? 64 out of 225. How do you want to write it? Well, that's fine. 64 to you want to write decimal, you can, I guess. This is or equivalent. Alright, 8 over 15 times 8 over 15 it is. Question 10. Question 10, and we got Mina makes these patterns using dots and lines. I don't know why she does that. Draw pattern 4. So let's check. Pattern 4. Okay, I recommend using a pencil for this one as well. If you make mistakes, you can rub it out. You see now there's a dot. 1, 2 squares, another dot. 2 squares, another dot. 2 squares, another dot. Okay, and this time we're going to have one more. Then above that, there's a dot, a dot, a dot, and this time we got 4. I recommend using a ruler so it looks neat. They think you're smart. They don't hesitate to give you your marks. Bit ugly, but it's there. Not very helpful in the mark scheme. Okay. Complete the table. Number of dots 3, 5, 7. You see it. There's 5. Goes up 2 more every time. 2, 4, 6. 2, 4, 6, 7. 2, 4, 6, 8, 9. So 2 more every time. Number of lines is 4 more every time, so that must be 17. Okay. Write down the term-to-term rule for continuing the sequence for the number of dots. Number of dots. Right, we're adding 4 each time. So to get from one term to the next, you add 4. It's always not the nth term rule. Okay. Oh my goodness. You're adding 2 each time, of course. It's not the nth term rule. It's just you adding 2. Add 2 or equivalent. So just plus 2, it will be fine. Okay. Not the nth term rule. Don't confuse it with the nth term rule. Okay. That's the next one. In terms of n, find the number of dots in pattern P. Okay. So if we're adding 2 each time, it is not n plus 2. Just make this clear. That is wrong. Okay. When you're adding 2 each time, it's just like this pattern, which is the 2 times table. So that will be 2n. Okay, but this pattern starts at 3, then it's 5, then it's 7, then it's 9. So it's 1 more each time. So it's like the 2 times table, but just with 1 added. So 2n plus 1 it is. Okay, then they give us the nth term rule for the number of lines. Okay, now the number of dots, the number of lines, oh my goodness. So let's first of all, which pattern is going to have 129 lines? So let's write down what they give us. Now remember, if we put the n in there, we get the pattern number. That will give us 129 lines. So let's solve this. Let's first subtract 1 from both sides to get rid of that 1. That's 128. And then we divide 4, which will give us 32. So if we continue this pattern up to the 32nd one, the number of lines will be 129. So to find the number of dots, we need to use the rule for the number of dots, which is that one. And put that 32 in there, and it will tell us how many dots. So that will be 2 times 32 plus 1. Remember now we're using this for here for the number of dots. What is that? 64 plus 1 is 65. 65 dots in the 100, well, with this 129 line. Very important, not from wrong working, okay? So you need to do the working out correctly as well to get full marks. And that was the last question on the paper, and I believe also the hardest one, but you're smart and you can figure these things out. Well done for working so hard. See you again soon.